Okay. Assalamu alaikum. I hope this is working again. So today I'll be doing section 11.8 and 11.9. So I'm going to start with 11.8, which is power series. Okay. Now, what is the definition of power series and why do we need it? So definition. Power series is a generalization of polynomials. So for example, I can say that every polynomial can be expressed as a power series. Okay. Now, the idea here, or the common form of power series is the following. It's going to be summation from n equal 1 to infinity. Now, there is nothing special about the 1. It could be 0, could be 1, could be 2, whatever. It's going to be some constant, let's say, c and whatever. Like, it could be any constant. That depends on n, okay? Or it could be a fixed constant multiplied by x minus a power n, okay? So this is the common form of any power series that you will see in this chapter or in this section, okay? Now, you can represent technically any polynomial as a power series like this. So it's a series that does not have only n, it has an x, okay? Now, you could have a function of n here as well. So for example, I could have n multiplied by x minus a all power n, or root n, or len n, or like some combination of functions. It doesn't really, there is no restriction on this at all. The most important thing that you have is the x. Okay, the most important thing that you have is the x. So what we want to study here, we want to study the following. Does this form of series, which is power series, converge or diverge? And if it converges, when does it converge? That's the idea. If it converges, when does it converge? Okay? So I'm going to start with some important notes here. Okay? So, important. If that power series converges, then the sum must depend on x, depend on x value. Okay, the sum must depend on the x value. Let's take an example on this, which is something that you've seen before in 11.2. Okay, so let's take an example. So consider the series n equals 0 to infinity of x power n. Very basic example, but this is something that we've seen in 11.2. If you remember in 11.2, what we did, we studied geometric series. And geometric series had this form: summation a constant times r power n. Okay, and we said that this summation, if it converges, then it's the first term a0 divided by 1 minus r. We said if it converges only, this formula will be true. Okay, now this is exactly what I'm doing here. Now, and we said when does a geometric series converge? Converge if absolute value of r less than 1. Okay, so this is the exact same thing here. This is technically a geometric series. Okay, this is a geometric series. Converge if absolute value of x less than 1. The same exact thing. I just replaced the r with x because x is not a constant anymore. The x is something I can control. Okay, x is something I can control and change. So now, if that series converge, then the sum of that series, what would it be? It would be the first term. So you plug n equals 0, you will get, let me erase this. You plug n equals 0, you get 1 divided by 1 minus the ratio, which is x. Okay? This formula that I just obtained, 1 over 1 minus x, is basically what we call the series representation of this function, 1 over 1 minus x. And we will dig more into this in 11.9, okay? But for now, I just want to show you that this formula is true. This is true for absolute value of x less than 1, which means that x is between minus 1 and 1. Okay, this is what we need. So now, the series converge for every value of x between minus 1 and 1, and the sum of that series will depend on x. It's 1 over 1 minus whatever that x is. Just the only condition that x has to be between 1 and minus 1. Okay, so the sum is a function of x. Okay. Now, so let me just some important note here. Note. So when we deal with power series, we face only one of 3 possibilities. And this is very important to understand what we need to do in the questions. Okay, number 1. The series converge for or only when x equals a. What does that mean? Look at this. If x is equal to a, then a minus a, that's 0. So you are summing 0 plus 0 plus 0 plus 0. So this statement is true. The series converge only when x equal a. This could potentially be true. This doesn't mean that this is the only case that can happen. But this will definitely happen, right? Because if I plug that a, okay, and we will denote it by something. Actually, a, we denote it by, a is called the center of the power series. Center of the power series. Power series, okay? Or another notation we can say, or we can talk about the series that, or this, or whatever this is, power series centered at x equals a. Now, to find the center of the power series, the coefficient of x has to be 1. Okay, this is extremely important. The coefficient of x has to be 1 if I want to find the center of the power series. Because as you will see in the questions, it's not necessarily 1. Okay, so we will have to do some adjustments. All right. Now, the second possibility that we might end up with, the series is convergent for all values of x in the interval minus infinity to plus infinity. Okay, any value of x you plug, you will converge. We will see an example on this. Okay, so 1 and 2 honestly are not very common. The most common one is the third scenario, which is basically the series converge for some x in a specific interval, in a specific interval, and we denote that by I, okay? And we call that I is called the interval of convergence. Interval of convergence. Okay? Very important quantity that we will keep calculating here. Every question on power series in the exam, they will ask you calculate the interval of convergence, and they will ask you also calculate the radius of convergence, which I'm going to define in a bit. Okay? So let me just give you a little more details on this, and then we can solve questions. So case 3 is the most common case. That doesn't mean you ignore case 1 and 2, but case 3 is the most common. Now, case 1 is always true. This is always true, but you could have this or you could have this, okay? But these two include this automatically. If the series is convergent for all x in minus infinity to infinity, then it has to converge at A. And if the series converges at some interval, then that interval must contain the center of the power series, and you will see now. Okay? So cases 2 and 3, they contain automatically case 1. So here, very important. Okay. So I, which is the interval of convergence here, is always centered at x equals A. That's why we call it power series centered at A, because it is also the center of the interval. If you have an interval of convergence here, okay? Now, another notation that we need to do, if I have a number line representing that interval, let's say I have some A here, okay? Then the distance from A to the end point of the interval and the distance from A to the beginning of the interval, okay? This distance here is the same as distance here, which we call R, which is the radius of convergence. Okay, R is called the radius of convergence. It's called the radius of convergence. R, you can find it easily by just doing what we're going to do in the solutions, or if it confuses you, you can construct the interval. And once you construct the interval and locate the center, then you can, just like by using numbers, this will be a number, this will be a number, this will be a number. So you can see how much is R automatically, okay? So, okay. So let me give you an example on this, just a practical example that we did before. Example, for geometric series, the interval of convergence, if you notice, was -1 to 1. If you look here, x is between -1 to 1. This is exactly the interval of convergence, and it's open. Okay? So now, by just looking at the interval, I can just remember, or I can just deduce that the radius of convergence is 1. Okay? And the center is 0. Okay? By just looking at the number line, I have -1 to 1. Okay? What is the middle point between them? That's 0. That's the center. It's the middle point of the interval. And the radius is the distance between the center and the end, or the center and the beginning. Okay? And it's always, R is always a positive number. Okay? It's always a positive number. Now, So we have just a warning here. So you have to note that I could be on the following form. Could be on the form it could take any of the four forms, okay? D to C, closed at D, open at C, or open at D, closed at C, or closed at D, closed at C, or open at D, open at C. Okay? So any of the interval endpoints could be open or closed. So I have four possible scenarios. Okay? How am I going to figure out that this is open or closed, open or closed? So here we will figure it out by solving. You will see. Okay? But you have to know that we could end up at any of these possibilities. Okay? Now, actually, when you solve, you're always going to end up with this open interval. Okay? And then when you need to check the endpoints, you check the D and you check the C. Okay? And you check if the series converge at C, for example, then I close the interval at C. If the series converge at D, then I close the interval at D. If it converges both, then you close both, and so on. Doesn't converge at any, then you open both. Again, this is called interval of convergence. For example, if it converges at -1 here, then -1 is contained in that interval. It has to be a closed interval, and so on. Okay, but for the geometric series, we know at -1 and 1, it does not converge. It does not converge. Okay, so let's take an example and see how we're going to solve the example. Okay, so okay, so the examples will be on the following form. Determine the interval and radius of convergence of the following power series. N equal 1 to infinity. Now, note, when we solve, okay, when we solve, actually, all the questions that we solve, we will use ratio test. Someone will come and ask me, can I use root test? Yes, you can. But ratio test is much easier to deal with in these kind of scenarios. Okay? So note, we will use ratio test. Okay? Always. Now, I'm studying convergence. Ratio test converge. Ratio test converge if the limit as n goes to infinity of the ratio is what? Is less than 1. So I want to make my series, the ratio of my series, less than 1. Okay? And then from that, I'm going to solve for x. Okay? From that, I'm going to solve for x. And then from that x, I'm going to know the interval, and then I can know the radius. Okay? Now, something to note down. To know the radius of convergence by just looking at the problem, you can use the following like formula. Okay? Once you reach this form, x minus a less than something, that something is r. Okay? And whatever number here is the center of the power series, and whatever number here is the radius of the power series, the radius of convergence. But x has to have a coefficient 1. It has to have a coefficient 1. It has to be an x, not an x squared, not x cubed, nothing. It has to be just single x power 1. That's it, with coefficient 1. Okay? So this is what we're aiming for. Once you reach that, that number here will be A, that number here will be R automatically. I'm going to show you while solving. If that confuses you, you can just construct the number line, and I'll do both actually. Okay. So let's see. So the solution, the procedure is always use ratio test. Again, you can still use root test, but here the ratio test is much simpler. Okay. So we take limit n goes to infinity of absolute value of an plus 1. So you add plus 1 to n, not to x. X stays x, okay? And then here I have n plus 1 squared plus 1 times the reciprocal of an. So n squared plus 1 divided by x minus 2 power n. Now, I'm doing convergence. I'm trying to conclude what value of x will make the series converge. So what value of x will make this limit less than 1? Because in ratio test, when do I converge? When that limit is less than 1. Okay? Now, let's do like the exponent rules and stuff. So let's see. So I have x minus 2 power n times x minus 2 divided by plus 1 here. Just copy pasting. Okay. Now I can cancel. And when I solve, I prefer to collect the similar terms together so I can see them in a better way. Okay. So this becomes limit. Or 1 second. Let me write it here. Limit n goes to infinity of absolute value. Okay, I'm going to put this with this. So n squared plus 1, n plus 1 all squared plus 1 multiplied by x minus 2. Now, someone might think that I have to remove the absolute value. No, I don't. Actually, if you remove the absolute value, you are making a mistake. So here, I know that in 11.6, when we solved, we ignored the absolute value sometimes because there was no negative, okay? Like negative 1 to power n to cancel. But here, you don't know what x is, okay? So you have to keep the absolute value. You don't know what x is. You are not sure if this expression is always positive or always negative. So here, in this context, do not remove the absolute value. If you removed it, you destroyed the objective of the question, because to get an interval, you have to still have an absolute value in the inequality. Okay? So let me keep this less than 1 again. So this has to be less than 1. Okay. Let me continue here. So now I have to evaluate this portion of the limit alone. Now this portion of the limit, if you look at it, it's n squared plus 1. Here n squared plus 2n plus 1 plus another 1. But you know, these limits are polynomials, so you can take the leading powers. So you have n squared here and n squared here. So this portion, all of it, is just 1. Okay? So this is equal absolute value of x minus 2 less than 1. Again, that limit is just 1. Just expand and you will see that there is n squared here and n squared here. And then n squared over n squared. Remember, don't plug the limit in x. The limit is for n. You are solving for x. So you get rid of everything in terms of n, and then you end up with a situation with a scenario like this now. Okay, with an expression like this. Okay? Now, notice that this guy exactly matches this guy. I told you, if you have an expression like this, x to power 1, coefficient 1, okay? That number here is a, that number here is r. So now, automatically, I can just, without looking, I can just say a, the center of the power series is 2, and r is 1. If you still don't understand how I got these, okay, you can just simply solve the inequality. Anyways, you have to solve the inequality. If I have an inequality with absolute value, how do we do that in math? We just say x minus 2. We make a copy without an absolute value. And then we copy this here. So we're just going to say larger than, the same direction. And then instead of positive 1, you put minus 1. You add 2 to both sides. So x is 1 between 1 and 3. So now my interval of convergence is 1 to 3 open interval. And as I told you, we will always end up with a situation like this, but I cannot accept this as a final answer yet. I have to check the endpoints. Maybe one of them is closed. I don't know. I have no idea. So I have to check. Okay? Because think about it. If x is equal to 1 or x is equal to 3, if you plug these in the limit here, the ratio will be exactly equal 1. And we know at x, if the ratio is 1, the test fails. So we don't know. Okay? So now we need to check the end points. So this is not done. This is not done. We have to adjust it or keep it, but I need to check the endpoints. Okay, check x equal 1. So what do I mean by check endpoints? Plug x equal 1 in the original series. In the original series here. So what do I get? Okay, 1 minus 2, all power n is just minus 1 power n divided by n squared plus 1. Okay, now you just constructed a question that you should solve using any test that you took before. Okay, you just constructed a series question, a regular series question that this is not a power series anymore. This is a regular series question. It's all n. There is no x in it anymore. Okay, so looking back at the previous test, what do we have? Divergence, LCT, DCT, integral, blah, blah, blah. But this is clearly what? Alternating series. I have a minus 1 to power n. So we can say apply alternating series test with Bn equal 1 over n squared plus 1. Remember, Bn is everything except the minus 1 power n. Okay, this is decreasing. Why is it decreasing? Because the derivative is negative. Okay, so let me write it in brackets. So for f of n equal 1 over n squared plus 1, then f prime of n is equal minus 2n divided by n squared plus 1 all square. Okay? You can apply quotient rule to end up with this. Now, this guy, 2n is always positive because n is from 1 to infinity. And n squared plus 1 all square is always positive because it's square. So I have the minus times a positive over the positive, so that's always a negative. Okay? That's it. So Bn is decreasing. Now also, the limit as n goes to infinity of Bn equals 0. Remember the conditions of alternating series, the limit of Bn has to equal 0. Therefore, the series is convergent. The series is convergent. Which series? This series. Which happens where? At x equal 1. So the series is convergent for x equal 1. So now I have to update my interval and close it at 1. I have to close it at 1. Okay? Now I have to do checking for x equal 3 now. So let's do that. Let's do that on the other side. Okay. So now plug 3 minus 2 is 1 power n. 1 power n is always 1. So just it's going to be 1. Okay. Now this looks something like a P series, a convergent P series, because I know that 1 over n squared alone convergent, P equal 2. Okay. So I can say we apply what? Which test should I use? We can use LCT. Apply LCT with an equal 1 over n squared plus 1, and bn is the approximation, which is 1 over n squared. Now, take the limit now, n goes to infinity, of an multiplied by, it's an over bn, but instead of saying an over bn, I will just say an multiplied by the reciprocal of bn, which will be n squared. So it will be something like this. And that series is equal to 1, leading over leading, which is larger than 0, using the LCT rule. LCT tells you this has to be a finite positive number, not infinity, not 0, not negative, or not oscillating. Yeah, it does not exist. Okay? So that limit is finite. So what does LCT tells me? That an has to behave like bn. So since the series of bn, which is 1 over n squared, converges, then the series of an here has to converge. Also converges. But take a step back now. This series, how did I obtain it? By plugging x equal 3. So the power series is convergent at x equal 3. So the power series converge at x equal 3. So now I have to update my interval, which is this guy. It's the same. So now interval of convergence, interval of convergence. You could write it like this. You could write x. Now the series is convergent at 3 and convergent at 1. So I'm allowed to put equality. If they diverge at 1 or diverge at 3, you don't put equality. Okay? And, so, or you can say from here, I equal closed interval 1 to 3, and R is equal to 1. Okay? This is what they need. Now, let's say you are not convinced how I found R from here by just comparing it to the form that I was writing here before. How would I obtain R equal 1? You can just draw I. Just draw it on the number line. So what do you have? 1 and 3 here and here. Okay? You can obtain, by knowing the interval, even before checking the endpoint, by knowing the interval, you can know the center of that interval and the radius. The center of that interval is the center of the power series. So what is the mid distance? What is the mid number between 1 and 3? It's just 2. And what's the distance between 2 and 3? That's 1. And what's the distance between 2 and 1? That's 1. That's it. So the center of the power series is 2, which we said A equal 2 by just comparing here. And the radius is 1. Okay, one more example. Same thing. Determine the radius and interval of convergence. Okay. Okay. Again, you apply the ratio test. Okay. Apply ratio test. Okay. So you say limit n goes to infinity of absolute value. Again, we keep the absolute value. The whole thing is revolving around the absolute value. If you don't have absolute value, you cannot solve the question. So an plus 1 over an, يعني multiplied by the reciprocal of an. Okay. Now I just have to write this nicely. So limit n goes to infinity of. Now this is what? X power 2n times x power 2. Yeah, this is 2n plus 2. So you split it using exponent rules. And this is n plus 1 multiplied by n factorial. And here I have n factorial x power 2n. Okay? Now, cancellation. This cancels with this. This cancels with this. Of course, this ratio has to be less than 1, right? Okay. So let's see what we have in the limit. Limit n goes to infinity of absolute value of. Let's write the x alone and the n alone, okay? So I have 1 over n plus 1 times x squared. Okay? Times x squared. Has to be less than 1. Plug the limit first. You cannot find the radius and the interval without plugging the limit. You have to plug the limit first. This is what I did in the previous question. If you plug the limit here, what do you get? You get 0. And 0 times x squared is what? 0. So ratio test give me 0. No matter what x is, 1 minus 1, 2 minus 2, 3 minus 3, whatever, I got 0, the answer. So now, this is true for all values of x. Whatever x, think about it, just logically, whatever x you plug here, multiplied by 0, it will be always satisfying this inequality, right? What is the difference between this question and the previous question? Because the previous question, we ended up with an expression with x. The n expression ended up to be 1. But here the n expression is 0. Multiplied by x is always 0. So whatever x you plug, you will get 0. Okay, which is always less than 1. So what am I trying to say from this? That the series converge for all values of x, which means that the radius of convergence or the interval of convergence is plus or minus infinity. Minus infinity to plus infinity. يعني every point in that interval, if you plug x in every point here, it will converge for all real numbers. And r is infinity. Okay? The radius is infinity. That's basically it. Okay? So I hope this is clear. This isn't a very common type of examples, but it could appear, you know. So, but what's more important is you understanding how to find the interval and radius of convergence here. Okay. Maybe let me do one more question on this. Okay. And then I can move to 11.9. Okay. Okay. Again, determine the radius and interval. We have 3 power n plus 1 times root of n. So the series could be very complicated, but the most important thing that it has an x. That's why it's a power series. Okay. So again, the same procedure. Apply ratio test. Ratio test. Okay, so we say limit n goes to infinity of absolute value a n plus 1. So it's n plus 1 minus 1, so it becomes n. You know? And here n plus 2. And here root n plus 1 times the reciprocal of an. Just copy pasting this. Okay, just copy pasting this. Okay. Fine. Try to simplify some stuff. Remember that the limit has to be in the end less than 1. You can write this in the end if you want. That's completely fine. So here, I can write this as 3 power n plus 1 multiplied by 3 power 1. The root, I cannot change anything with it. You cannot split the root on addition, please. Don't do it. Okay. And then here I have what? 1 minus x power 2x power n times 1 minus 2x power negative 1. Okay. Now, the power n's cancel. 3 cancels, power n plus 1. This 1 minus 2x power minus 1, you can take it up, becomes power 1. Okay, because anything down with a negative power becomes up. So 1 minus 2x, I'll write it over 3, and then I'm going to write the root with the root together, like this. Try to isolate the n from x better. Okay. Now, what you can do to evaluate this limit, you can combine them both in one root, because square root distributes on multiplication or division. Multiplied by root n over n plus 1. Now, if you think about it, the inside, the leading term is 1 over 1. So this is 1, root of 1 is 1. So that's it. We're done with the n part. And then we have left the square root, the absolute value, 1 minus 2x over 3. This is the answer. Remember, this answer essentially is always less than 1, less than 1, less than 1, less than 1. Okay? And then you solve. Okay? And then you solve. So you're just going to do it like this. Absolute value 1 minus 2x less than 3. So basically what you have here is what? I just multiplied 3 on both sides. Okay, and then you can break the absolute value. How do you break the absolute value? Again, same as the previous question. Just put 3 here, minus a 3 here. Okay, and then you need to manipulate it. So, okay. Or, what you can do, you could take minus 1 out. So you could subtract 1 first. So what do you get? You get minus 4. And then 2 here. Okay, just subtract 1 from both sides. And then I have to divide both sides by 2. Minus 2, sorry. I have to divide both sides by minus 2. So you end up with negative 4 divided by negative 2 is 2. 2 divided by negative 2 is negative 1. Since you divided by a negative in the inequality, you have to flip all the signs. So it becomes like this. Okay. You can write it. You can. I'm just writing it, so it will be like this. It will be x less than 2, larger than minus 1, like this. Okay? This is nicer. Because if you read it slowly, this is x larger than minus 1, x larger than minus 1. And then the same thing here, x less than 2, x less than 2. Okay? That's basically it here. So the interval is minus 1, 2, but I'm not done yet. I have to adjust it. Not done. So be careful. But from here, if you want, you can look for the radius and the center, because just by drawing the interval, you can notice. But let's do it in the end. Now, I have just to check the endpoints of the interval, and that will be it for this question. So check x equal. Let's start with x equal. Let's start with minus 1. So plug minus 1. You obtain a new series now. Okay, minus 1. So this becomes 1 plus 2, 3 power n minus 1. 3 power n plus 1 root n. Okay, now you can that's actually a cancellation between this and this, but if you cannot see it, then you can write this as this. So this becomes what? 3 power n minus 1. Here you can write it as 3 power n minus 1 times 3 power 2. Because, when you add them together, you get plus 1. Or you can do it in whatever way you want. Some people will take it like this, and then subtract. Since we have exponents, we're dividing, then we can subtract the powers. So it becomes like this. And then like n minus 1 minus n minus 1. So 3 power minus 2, And this is what I'm going to obtain right now. Okay? This is what I'm going to obtain. Whatever way you want to do it, you do it. Just do it right. Okay? So here, and then the 3 power minus 2 I was talking about is this just on the top, yani. So this is basically series 1 over 9 root n. But if you think about this, you can look at it like this: 1 over 9 series 1 over n power half. So here, this what happens to this? This diverge, because p, this is exactly a p series. P equal half, divergent. P equal half, so divergent. Okay? So it diverges the series diverges at x equal minus 1. So I keep it open. I don't close it. I close it only when the series converge at that number. Now check x equal 2. So you have 1 minus 4 is minus 3. Minus 3 power n minus 1. 3 power n plus 1 root n. You know what's the difference between this series and this series? Just the minus 1. The minus. So here, what you can do, you can say this is exactly equal to what? Minus 1 power n, 3 power, minus 1 power n minus 1, 3 power n minus 1, 3 power n plus 1 root n. But I already canceled these. Like I already did the calculation here. It's just that I have a minus 1 power n minus 1 sticking out here. So this is equal to what? Same exact thing here. Just with minus 1 power n minus 1. Here 9 root n. That's it. So what type of series is this? This is not p here, because p has to have 1 on the top, just positive. This has a minus 1 power n. This is alternating. So you apply alternating series test, okay, with bn equals 1 over 9 root n, which is decreasing. You can show them the derivative, okay, and limit n goes to plus infinity of bn, just plug it, 1 over infinity, that's 0. So the two conditions are satisfied. You can check decreasing by just taking the derivative. Let me show you here. So if f of n 1 over 9 root n, then f prime of n is just derivative of the top times the bottom, that's 0, minus the derivative of the bottom, like this, divided by, so this is in brackets, huh? Like, 1 second. Again, minus the derivative of the bottom, which is 9, multiplied by 1 over 2 root n. That's the derivative of root n. Divided by the denominator squared. So this is 81n. This is always, all of this is always positive except the minus outside, so this is always negative. Okay? And we already said that the limit is 0. So series converge for which value of x? X equal 2. We plug 2. Therefore, the interval of convergence, let me rewrite it again. Now let me update it. It converges at 2, so I close it at 2. It diverges at 1, at minus 1, so I keep it open at minus 1. That's it. So minus 1 to 2. And then the radius, if you don't know how to find it, you can just construct the number line. Minus 1 to 2. What's the middle point between them? Actually, you can look at it from here. Always the center of the series. Always, always, always. If the expression is very complicated, the center is what makes this guy 0. What makes the bracket that has x 0. So 1 minus 2x equals 0. What is x? Half. Okay? And then, what is the distance from half to 2? 3 over 2, or 1.5 yani. So this is r, and this is r. So r is just 3 over 2, and here 1.5. That's it. Okay? That's it. You will lose a lot of marks if you did not adjust this. You have to show them that you checked. Even if both were convergent, عادي, خلص يعني, then you don't adjust, but you have to show them that you checked this. Okay, I hope this is clear. Let me start 11.9. Okay. Okay. Okay, 11.9. So this is power series representation of functions. Okay. Now, let's go back to something we did in 11.8. So we said that the summation n equal 1 to infinity or 0, 0. We said 0. That's not necessarily 0. That doesn't matter that much. X power n is 1 over 1 minus x. We said that. We said that this summation is 1 over 1 minus x. Now what we're going to do in this section, I'm going to give you a function, and you're going to represent it to me as a power series. So I'm not going to give you this. I'm going to give you this. Or not exactly this, like variations of this. So for example, I can replace x with what? 2x. I can replace the one here with 5. I can replace the one here with 10 or anything. Okay? And then you have to manipulate it. You have to do some algebra. Or even worse, differentiation or integration, in order to reach something like this that you can convert to a power series. So here, we don't change the power series to a function. No. We change the function. You're gonna be given a function, and you're gonna end up with a power series. So I like to explain this section in by giving just 3 basic formulas. Or sorry, 3. I'm just gonna group the situations into 3 different groups. Okay. So basically, we have the basic rules. Okay. So for example, 1 over 1 minus x is always equal to series n equals 0 to infinity x power n. And 1 over 1 plus x equal series n equals 0 to minus 1 power n x power n. These are the 2 basic rules. Okay? Just like memorize them. Okay? I'm going to give questions. I can start with questions now based on these. Okay? So I can start with questions now. So example. And remember, they will ask you for the radius of convergence of this. How do I get it? Remember that this converge when? This converge if absolute value of x less than 1. We just said that in 11.8. And the same thing here, by the way. Still, this is a geometric series, technically. Converge if absolute value of x less than 1. So the radius of convergence is technically 1. Here, the same thing. R equals 1. And here R equals 1. Okay. So let's have some examples. Represent the following functions as power series. Okay, number 1. And then also mention or find the radius of convergence. In this section, we are dealing with power series that have always center 0. If you notice, this is power series centered at 0. A equals 0 here. We usually had what? We usually had series x minus a power n. But now we have just x. So a is 0. Okay? So I have no center here. So whatever number here, such that x is coefficient 1 and power 1, whatever number you see here, that's always the r. Okay? So let's take an example to understand this better. So f of x equal 5 divided by 1 minus 4x squared. Okay. Now, essentially here, we want to generalize this. We want to generalize this rule. We want to generalize these. What does that mean? Now, the most important thing that I have to have is the 1 and the 1 here, and the 1 and the 1 here. That's it. Here, instead of x, I could have anything. I'm just going to put literally a box. That box could contain anything. Okay? It could be x, could be 5x, 4x, 2x cubed, whatever. And the same thing here, converge if the box, the radius of the box is less than 1. Sorry, the absolute value of that box less than 1. But here I cannot say that r equal 1 anymore, because I have to isolate x to power, I have to make it x power 1 and coefficient 1, and then I can say that that number is r. So we will see in this example. Look at this example. Again, I told you that we have to have a 1 here and a 1 here. Now, how can I have a 1 here? I can just kick the 5 outside. So I can write it like this. 5 multiplied by, so the solution starts here. Solution, f of x can be written as 5 times 1 divided by 1 minus 4x squared. See, I have 1 and 1 minus something. That's the box here. Okay, now I can change this to a series. N equals 0 to infinity, always 0 to infinity here. Okay, now this is 1 over 1 minus something here. Use this rule. So instead of the box, I have 4x squared in the box. 4x squared all power n. And they said find the radius of convergence. So this converge if the thing inside the box, absolute value less than 1, always less than 1. Okay, because these are geometric series we're dealing with. Okay, now the radius isn't 1 now. Okay, the radius is not 1. You have to isolate x. Divide by 4. Take the square root. That's it. So here, now I isolated x. It's power 1, coefficient 1. This is r. Without any further calculation, I can find r. He did not ask you to find I here. I don't think they will ask you in the exam to find the integral. Okay? They are mostly concerned in this type of questions in 11.9 with the radius of convergence. Now, let me just keep this. If you want to simplify this further, let's say you would like to do it. Sometimes it's better. You will see why later. We can insert the power n, distribute it. Becomes 4 power n, x power 2n. And here I can keep the 5 outside. Okay. You will see that it's better to simplify it sometimes because we have more rules than this, so we have to do more work. Okay, but let's do another example. F of x equal the same thing. Represent as a power series. Give me the radius of convergence. So 4 divided by 2x plus 3. Here, first deal with it 1 by 1. I have to have a 1 here. Okay. So now solution. F of x equal. So 4 multiplied by 1. Here, instead of 2x plus 3, I will write it as 3 plus 2x. Why is that? Because I'm used to this form. I'm used to 1 over 1 plus the stuff in x. Okay. So to clear out confusions or to just have it look better, you know. So, okay. Now I have to have 1 here instead of the 3. So what do? I take 3 as a common factor. So 4 times 1 over 3 multiplied by 1 plus 2x over 3. Now, like, kick the 3 with the 4, yeah, and you can write them like this. Really, there is no effect at all. Just a matter of algebra. Now I have what? 1 over 1 plus something, the box. Now you can find a series out of it. This is series. This is the plus version. So it's minus 1 power n multiplied by the stuff inside the box, power n. From 0 to infinity. Okay. Now, yeah, what's the radius of convergence? Radius of convergence is, so I cannot find it immediately. I should say converge for absolute value of the thing inside the box has to be less than 1. Multiply by 3 and divide by 2, so you get absolute value of x less than 3 over 2, and that's exactly the R. Okay, that's exactly the R. If you want, you can expand. Like you could write it like this. You can have minus 1 power n, 2 power n, x power n, 3 power n, and you can do more. Okay, you can say that 4 is 2 squared. Okay, and you can insert also the 3, so it becomes like this. Plus 2 x power n divided by 3 power n plus 1, because 3 power n times 3 power 1. So that's the full series. Okay, you can do that. You can do that, it's fine. It's nice to do it sometimes. Okay, and you will see that we have to simplify completely sometimes in some questions. So, but these cases didn't come yet. Okay, I'll do one more, and then we can move to the more complicated stuff. So let's say I have f of x equal x divided by 2x squared plus 1. Let's say I have an x on the top, not a constant. Okay, fine, sure. So you deal with it like you deal with a constant. So solution. So f of x equals, take the x out, becomes 1 over. You write this as 1 plus 2x squared. Yeah, I just reverse the order of addition. Done. I'm done. 1 over 1 plus something. So the x stays out. That guy is minus 1 power n 2x squared power n. Now let's immediately, after you find this, find the radius of convergence, because it depends on whatever is inside the box. So converge if absolute value of 2x squared less than 1, which means that absolute value of x squared less than half, not enough. You have to be x power 1 coefficient 1. So 1 over root 2. So that's the R. If you want to simplify further, we can do this. We can just say n equals 0 to infinity minus 1 power n, 2 power n, x power 2n. Okay? And you can also insert the x inside. Okay? You can insert the x inside. So you end up with this. N equals 0 to infinity minus 1 power n, 2 power n, x power 2n plus 1. And that's it. That's basically it. Okay? Okay. Fine. I just want to do one more, because I just thought about this kind of examples. A very, very basic thing, yani. Let's say I have not one even. It's fine. Make anything here. 2x divided by x squared minus 5. Okay? Now, here I have to have something minus x, a number minus x, not x minus a number. So how can I do this? You can take a minus out, like this. It will be like this. It will be exactly like this. Take a minus out. So it becomes minus 2x multiplied by 1 over 5 minus x squared. You can take the 5 as a common factor. 1 over 5, 1 minus x squared over 5, which means that minus 2x divided by 5 1 over 1 minus x squared over 5. And that's it. You end up with a series. So this is minus 2x over 5. Series 0 to infinity of, it's 1 over 1 minus something. So you just take that thing, power n, and that's it. And this converge if what? This converge if absolute value x squared over 5 less than 1, multiply by 5 become 5, take the square root becomes x less than root 5, and that's the order. Okay, yeah, this is just another trick. Just thought about it, okay? But these are the different kinds of tricks, but really there isn't anything complicated here, okay? So, okay, now let's do differentiation and integration of power series, because I said that we have two basic forms and then we have more complicated forms, okay? So let's assume now again, we had what? What did we have? 1 over 1 minus x summation x power n here. And 1 over 1 plus x summation minus 1 power n x power n. Okay, now what if we have something like this? For example, f of x equal ln 1 plus x. Or like f of x equal tan inverse of x. Or f of x equal 1 over x plus 5 power 4. Let's 4. Why 4? 2. Let's have 2. Okay. These kind of functions, these structures of functions, ln, tan inverse, 1 over this. What is special about these functions? Think about it in this way. Let's differentiate this. What do I get? Derivative of the inside, which is 1 over itself. See, I got exactly this. Not necessarily this, like I could change this, I could change it, I could make it like 5 plus x squared, you know? And then f prime will be what? 2x divided by 5 plus x squared. But still I can replace this with a power series. I just did it here. I just did a similar example. So I can take the 2x out and the 5 out, and then I have 1 plus x squared over 5, for example. And that's the box here. Okay, you see? So I can go from ln to that common form that we studied before through what? Through differentiation. Through differentiation. Again, I can put the box here instead of x because it's more general. Okay. Same with tan inverse. What's the derivative of tan inverse? I hope you still remember. Forget about, let's not have x, for example, let's have x squared. So it's the derivative of the inside divided by 1 plus the inside square. I could still write this as a power series because this is what? 2x times 1 plus over 1 plus x power 4. And that's the box. Done. 1 over 1 plus something, you know? So I can write this through differentiation as a power series. Okay? And then, how about this one, the last one? Let me. Okay? How can I go from this to something like this? I will tell you. You will go You will go from here to there through integration. But again, these are common forms of questions. So I don't think you will get something more than len on tan inverse or something like this, 1 over some power square or cube, you know. So for len and tan inverse, you have to differentiate, then change it to power series, then you have to integrate back. We will solve a full question in details, obviously. And the same thing here. Here, how do you go from this to something like this? We can just go through integration. If you integrated x plus 5 power minus 2, I just take it up. This becomes x plus 5 power minus 1 over minus 1, which is minus 1 over x plus 5. Or you can write it as minus 1 over 5 plus x. And then take the 5 out. So minus 1 over 5 times 1 over 1 plus x over 5. Now you have a series. Okay? So you see that. I hope this is clear. I hope the different kinds of examples are clear. So here, we must introduce to you integration and differentiation in power series, because I can't write the power series of this unless I differentiate. Because I only have these two forms. That's it. I only have these two. Okay? So what functions can go to these two? I can go from len and tan inverse to these two guys by differentiation. And I can go from 1 over something squared to these guys by integration. These are common forms. They will come, yani as is, you know, len tan inverse or something over some bracket squared. Okay? So that's it. So if you have a len and tan inverse, so let's like summarize this. When we have len and tan inverse, what do? We differentiate first, then integrate. Because of course I have to cancel the effect of what I did. Let's see an example. Okay. So here, like summary of whatever I said. When dealing with len tan inverse, differentiate to reach the form that you need to write a power series, then integrate. So this is number one. Number two, when dealing with like 1 over or like some x plus a, maybe whatever, square or cube, whatever, okay, integrate, then differentiate. Then differentiate. Okay. Okay, fine. So let's have an example. Okay, let's have an example. The way it will come in the exam is something like this. Let me show you. One minute. Yeah. So part A, find a power series of f of x equal to x divided by 3 plus x squared. Okay. Here, again, you have to write it as 1 over 1 plus something, or 1 over 1 minus something. So this is equal to what? We can just simply say, take the 2x outside, and take a 3 as a common factor. So x squared over 3, which will be 2x over 3 times 1 over 1 plus x squared over 3. That's the box here. So 2x over 3 This guy, I will replace it with the series form of it again. Okay? So, minus 1 power n, x squared over 3 power n. And what's the radius of convergence? Let me write it. This converge if what? The guy inside the box, which is an absolute value, less than 1. Multiply by 3. Take the square root. That's it. This is the radius of convergence. Root 3. Part B. Use part A to find a series representation of f of x. They call it f of x. We call it g of x just to distinguish better. G of x equal len 3 plus x squared. In len, I have to differentiate to reach this form, right? So let's take the derivative now. G prime of x equal equal the derivative of that len. So what is the derivative of len? It's the derivative of the inside, which is 2x divided by 3 plus x squared. Okay? Now, what's this guy? This guy is exactly this. And this guy, I just made it to be what? This? Okay? So this is basically equal to. Now, here, this is why I have to simplify. Look. Let's simplify this. So this becomes what? Minus 1 power n. Now, x power 2n here. And then I will insert the x, so it will add 1. So x power 2n plus 1. And then I have 3 power n. And there is a 3, it gets inside, so plus 1. And then I have still a 2 outside. Just keep it outside if you want. It's fine. Okay? And that series is 2 n equals 0 to infinity minus 1 to the n x to the n plus 1 divided by, x to the 2n plus 1 divided by 3 power n plus 1. Because this, I just did it in part A. Okay? I just simplified. I expanded the power and then inserted the stuff inside. Okay. This is the series expansion of G prime. How to find the series expansion of G? I have to integrate both sides. So G is simply the integration of this guy, right? Or the integration of G, the integration of G prime, which is the integration of 2 times the series plus 1 dx. Since we're doing an integration, someone might ask me, this is very scary. How do I integrate a series? Like, should I change the series? It's no, you don't change anything. You take a deep breath, relax, okay? So basically what you need to do is just integrate x, that's it. Everything else stays the same. N stays the same, n stays the same. Nothing changes, just the x. That's it. How to integrate x power 2n plus 1? You add 1. How to integrate any x? You add 1 to the power, you divide by the new power. Power rule. That's it. No more, no less. So it becomes 2 times the series of n equals 0 to infinity. X power 2n, add 1, so it becomes 2. Divide by the new power. Power rule of integration, nothing more. Okay? Nothing more. And then remember, when I integrate, what do? I have to put plus c, right? So we put plus c here. Let's put plus c outside, so I don't mix it with the series, because it's not part of the series. Yeah. Okay? That's it. Now, some people, what they do, oh no, they don't do. Sorry, my bad. Never mind. So here, yeah, that's it. But this is not done. I have to find the C. Okay? I have to find the C. So let me do it here. To find the C, I have a very nice hack here, which is very stupid actually. But you simply plug x to be 0, so I can get rid of the series, and then I solve for C. So plug x equals 0. G of 0, G of 0 equals C plus 2 times the series, but here you have 0. So the whole thing will be sum of zeros, which is 0. خلاص. So G of 0 equals C. But what is G of 0? How can I find G of 0? You can go to the original function and find it. G of 0 by the original function is what? Len of 3. So here we plug in original also, because the original is equivalent to this أصلا يعني. G of x, which is len, is all of this. Okay. So C equal len 3. So finally, you just update your series. Len 3 plus that series. Okay. To here, minus 1 power n. I hope this is clear. That's basically it. A lot of algebra here. Okay. But honestly, I don't know. I hope it's not very bad. Yeah. Let's do one more. Oh, by the way, I just wanted to mention the radius of convergence of the series of the power series. The original power series is √3, right? We got it like long time ago today. Sorry, part A. The radius of convergence of the integration of that does not change. So the radius is also √3. Is also √3. Radius of convergence does not change by integration or differentiation. It does not affect it. If you integrate or differentiate the power series as much times as you want, the radius of convergence will not be affected. It will be the exact same. This is 3, so the other one, the integration of it is, sorry, so √3, the other one will be √3. Okay? I hope this is fine. طيب, okay. Let me do. Okay. Okay. Let's do this. So example 2 here. Find a power series of f of x equal x squared tan inverse x cube. Okay. Again, we said in tan inverse, I differentiate. Now you might ask me, should I differentiate the whole thing? No. The nice thing about power series is you can deal with it piece by piece. So like, I can just focus here. Focus here. And for now, just ignore this. Ignore the x squared. Ignore the x squared. Okay? So let's talk about tan inverse of x cubed. That's it. Just find a series for that. Okay? Because that's the one that's complicated here. So let's say g of x, let's say, equal tan inverse of x cubed. So g prime of x is what? The derivative of the inside over 1 plus the inside squared, which is equal to 3x squared times 1 over 1 plus x power 6. Now I can write this as a series. So this is 3x squared summation n equals 0 to infinity minus 1 power n x power 6 power n. And if you want to find the radius of convergence, sure, again, it's fine. So this converge if the absolute value of the thing inside the box less than 1. So here you get just x less than 1. So that's r equal 1. Yeah. Okay. Now this is for g prime, which is the derivative of tan inverse. Let me expand it. Let me insert the 3x squared. So g prime of x equal series. So this becomes minus 1 power n x power 6n. And then when you insert the x squared, you add 2, so plus 2. And then you have 3 outside. Just keep it, it's fine. That's the series for g prime of x. I want to find the series of g, so I integrate both sides. So when you integrate, you get, I'll put the plus c here. And then what do I integrate? I don't integrate anything in the series. I just integrate the x. So you just add 1 to the x, add 1 to the x, 6n plus 2 plus 1 becomes plus 3, divide by the new power. No more, no less. Okay? And then you find the c for g of x here. Now we find the c. To find the c, plug 0, the same trick. Plug x equals 0. So you get g of 0 equals c. The same thing. G of 0 equals c plus, here you have 0, all of this. Because x is 0. But what is g of 0? G of 0, what is g aslan? It's tan inverse. Tan inverse of x cube, which is 0 cube. And that's 0. So 0 equals c. That's it. So therefore, g of x updated, which is tan inverse of x cube. This is just 3 times the series without the plus c, because it's 0. No, sorry. X power divided by 6n plus 3. That's g of x, which is tan inverse of x cubed. Now, let's go back to f of x. It's x squared times this, but this I found a series for it, right? F of x is x squared multiplied by tan inverse of x cubed. So it's x squared times this guy, copy paste. So times 3 multiplied by the series. And then what you can do is you can insert the x squared here. You multiply, and you add 2 to the power of x. So overall, this is 3 multiplied by the series. X power 6n plus 5. 6n plus 3 here. And that's f of x. And then, again, the radius is the same. No matter how many adjustments you do, you only need one version of the series to have a radius, to find the radius of one version, and it will be the same across. Whether you differentiated, whether you integrated, it doesn't matter. Okay, it doesn't matter. Okay, let me have one more question as well. We covered the case of tan inverse, we covered the case of line. Let's cover a case where we have to integrate. Okay, let's cover a case where we have to integrate, then differentiate. Okay. Okay, number 3. Yes. Okay. So first, let me put 1 on the top. So solution. Again, find the power series of this function. So f of x equal x multiplied by 1 plus 4x all squared. Okay. Now, so I'm going to do here, I have to focus on this now. So if you want to call it g of x, call it g of x. Okay, integrate that. We said things on this form, we will integrate them. So the integration of g of x is what? You're integrating 1 plus 4x power minus 2 dx. So 1 plus 4x power minus 1 over minus 1 multiplied by 4 plus c. But how is this rule true? Remember, in integration, we said integration ax plus b power n is ax plus b power n plus 1 over n plus 1 times a. This is like called like power rule, but general form, yeah. Most general form. You could have a linear function inside, that's fine. Okay, so if you arrange this, you will get minus 1 over 4 times 1 plus 4x. Or you can write this as minus 1 over 4 times, because we're trying to isolate everything here, trying to have 1 over 1 plus something. Okay? All of this, remember, all of this is the integration of g of x. Now, I reach the form of my series, 1 over 1 plus something. So minus 1 over 4 series minus 1 power n, the box power n. Okay? Now, this guy converge if what? If the absolute value of 4x, the box, less than 1, which means the absolute value of x less than 1 over 4, and that's the radius. Okay? That's the radius. So, okay. So again, let's write it neatly. The integration of g of x minus 1 over 4 series minus 1 power n 4 power n x power n. If you want to insert it inside, you can do it like this if you want. You insert things fully, because you can insert the minus, so this becomes minus 1 power n plus 1, and then the 4 power n over 4 is 4 power n minus 1 x power n. That's the integration g of x. Okay? Now to find g of x, now we fully represented it as a power series. To find g of x, you differentiate both. So differentiate both sides. So derivative of the integration, they cancel each other, and derivative of the power series is exactly differentiating only the x. So what's the derivative of x power n from power rule? It's n x power n minus 1. Okay? Some people, what they like to do this. They like to say, since I differentiated, I'll change the starting index of the series to be 1. Okay? And that's true, they're right. But why they are right? Because, okay, let's say you kept it at 0. You know? And you want to plug now. So if you plug n equals 0, you have this n. You see it? It will be all 0. So the first term is 0. So it's redundant. Like it does not add to the summation anything, right? So for the sake of neatness only, not mathematical correctness, يعني both are mathematically correct. You can just say, I'll start from 1 after I apply every derivative. Because technically, when you plug 0 again, this is 0, so it doesn't affect the summation. Why is this important? Sometimes they bring it in MCQ. I'm not sure if you have MCQ in the exam, but in MCQ, for example, they play with this sometimes, and you have to spot it, okay? So that's why this is a little important. Okay, so this is g of x as a series now. But, okay, what is f of x? F of x is just x times g of x, because g of x is this, remember, okay? So f of x is x times g of x. So x times the series, that's it. Again, converges for the same radius. You can insert the x in, and that's it. So this becomes series equal 1 to infinity minus 1 power n plus 1, 4 power n minus 1, n x power n. That's it. And that's f of x. Okay. Now, some people can solve this question way faster. They can just observe that this is basically what? The derivative of this. Okay, but really, if you can do it faster than this, sure, but I did it really slowly just to show you detailed calculations, okay? You can do that as well. Or you can do it faster than me. It's fine. It's up to you. As long as you're doing everything correct, then it's fine. Okay? Let's do one last question, and then I'll go to solve previous samples. Okay. Evaluate. This is a different type of examples here. The integration of t divided by 1 plus t cubed dt as a power series. Honestly, this is really stupid. You want to evaluate the integration as a power series. Please don't think of any integration technique here. Just take the function and convert it to a series, and then integrate it. So here you have t times 1 over 1 plus t cubed, which is just t multiplied by the series, n equals 0 to infinity, minus 1 power n. Now, we don't have x, we have t. So t cubed power n. Okay? And this converge, the radius of convergence is what? Converge if absolute value of t cubed less than 1. So absolute value of t less than 1. That's the r. R is 1. Now, just simplify, because you cannot, you're still not done. You have to simplify, then integrate that function. So this is t power 3n. And then insert the t, so it becomes what? Plus 1. Okay? So now, the integration of that function is the integration of that power series. Again, dt here. How do you integrate this? You add 1, you divide by the new power. That's it. Don't forget, since we integrated, we have to put plus c. Since this is indefinite integration, I will just keep the c as is, and that's it. Okay. That's it. Okay. So this is the end. I hope everything is clear. Let me know if you have any questions. Okay. So I'll stop recording now, and I'll start the 2 samples with a separate recording. Okay. So that's it. Assalamu alaikum.